Hello viewers, in this video we will be developing a ToDo application which will be using the Hasura GraphQL engine for all the GraphQL queries and the REST endpoints. It will be using Keycloak for all the authentication, and we will be developing the front end and the server side code in the SvelteKit. So using the three technologies, the Hasura GraphQL Engine, Keycloak authorization server, and the SvelteKit, we are going to develop a ToDo application. And the SvelteKit application already has a ToDo demo application built into it, but it doesn't have any authorization kind of thing. And the API that the ToDo application uses for storing all the to-dos for a particular user are the public api.svelte.dev, which is developed by Rich Harris, the developer of Svelte and SvelteKit. So, but for our own understanding and knowledge, we will be seeing that how we can use the authorization provided by Keycloak, the JWT tokens generated by Keycloak, and we'll be using those tokens for the role-based access control for the GraphQL engine. The GraphQL engine doesn't have any authentication by itself. It uses the RBAC policies provided by the JWT token, and it will need some configuration to verify the token validity based on the JSON web key URL, the JWK URL. And so that was the intro. So let's go ahead and look at what we have. So currently we are having this Docker Compose file. Here we have the first service is the Mailhog service to test our SMTP mails and everything. This is a simple very demo mail kind of thing. Secondly, we have this Keycloak. The Keycloak will be sitting on its own demo network along with the Mailhog. I'm not using the default 8080 port because this 8080 port is busy on my system, and so I'm using the outside port mapping as 2080, and the Keycloak will be running on inside the container on the 8080 port. The default username and password will be the admin. The next in the line of services is the Postgres. Postgres will be mounting the PostgreDB data volume, which we have specified here, and it will be in the container. It will mount it to varlib PostgreSQL data, where all the PG, HBA, conf, and everything will reside. It will have the password as default password that I'm setting to the environment variable. And the last is the GraphQL engine. The image is the GraphQL engine beta version provided by the Hasura, and it will be exposed on the outside port as 18080. Okay, and it will be depending on Postgre. Once the Postgre starts, then this GraphQL engine will be starting. Here we in the environment variables we have provided the Postgre connection string, and we have enabled the console to be true so that we can set up various endpoints and test our queries. The dev mode is also true, but it may need not to be, and we have also provided the admin secret key here, but we can just uncomment it. But currently we will be using the RBAC and everything, so that's why I have kept the admin secret here. The JWT secret will be added in this list of environment variables, but first we will just start this Docker services through Docker Compose and up. We'll open a second terminal and see what's the status. Yes. The GraphQL engine and stopped showing the exit. Okay, I'll just shut down the services and start them again. it is up now. I think everything is up and running, so we will just go and test out. So I will go to the localhost 8080. That will be the endpoint for my Hasura Graphql Engine, my admin secret key. Okay, don't show me again. And do we have any tables made? No, we do not have any tables made. So first of all, we'll be creating a to-do table here. To-dos. It will be having UID, unique ID for each of the to-dos, and it will be of type UUID. We will be having random UUID to generate the UIDs by default. Then we will have user ID. It will be of type text. Then we will have the created at. It will be of timestamp. We'll give a default value of now. Okay. So the UID field is going to be a unique. Then the text, type text, and done will be of type boolean, and it will have value of false. The primary key will be UID, and we'll just going to add the table. We'll browse the rows. There are no rows currently. So by default, what Hasura will do for you, it will make some GraphQL endpoints for you, and using these GraphQL endpoints, we will be able to create the REST endpoints. Now a to-do application, the SvelteKit demo application uses this REST API endpoints, and so we'll be making these REST API endpoints based on the GraphQL queries that we write here. So the first query will be, just a second. Sorry for that. So the first query will be get to-dos for user, and it will be taking the user ID. It will be of type string, and it will be required field, and to-dos where user ID is equal to the user ID variable, query variable. We will be returning the UID, the created at, the text, and done. So I'll be just providing the user ID of Tushar here. We'll test the query. So currently there are no rows in the table, so it is returning a null. So it is good to go. I'll create a REST endpoint. What to do for user, description to user. It will be at to-dos, and in this GraphQL engine we define the variables using this colon user ID thing, and we'll be enabling the get method on this endpoint. So just like that, we have our first endpoint ready. Again, what I have to do, I have to create a mutation for creating a to-do for a user. To-do for user, it will be taking the user ID, which will be of type string. It will be taking the text, which will be of type string again. Insert to-do one. So object that we are going to be inserting is the ID, will be of type user ID. Text will be of type text. We will be returning created at UID. As you recall, we have given default values to the UID and done, so we just need to provide two of these, and we have also given default value to created at. So the created at will be generated using the now function, UID will be generated using the gen random UID function, and done is by default false. So we can just go ahead and test it out. Text smile, let's go ahead. So just like that, one of the entries were created. As you can see, the created at UID and done have come from the default values that we have specified. Now we will define the endpoint for it. Create to do for user, create to do for user, again to do's user ID, and we'll be defining post method on it. Just like that, we'll be creating our endpoint. Again, I'm going to define a mutation of type update to do for user. We'll be taking user ID type string. We'll be taking UID of type UUID. It will be taking text of type string. Will be taking done of $done type boolean. So update to do's where, okay, so it will be having two fields, and set, so where the user ID is the variable provided, user ID, equals user ID, and the UID will be equal to the UID, and we'll be setting the text to the query variable text, and setting done to query variable done, and we will be returning the created at UID text and done, because that's what accepts. Now we will just test this. We will copy this for now, and we will just fire a query to actually test query to this UID. Okay. To do actually there is no need for this. query for the that was the UID. I'll be creating the query variables. The user ID is star and the UID is the ID that we are receiving here. The new text is going to be smile more, and the done is going to be false. So as you might have noticed that the GraphQL engine gives a lot of suggestions to you when you are typing something. So that's all part of the GraphQL magic that you have. So we'll just test our mutation, and as you can see, the text has come to be smile more. Okay, so we'll just go ahead and make a batch call for it. It will be update to those for user. The location will be user ID as well as the UID points, and the last endpoint that we'll be creating is for deleting the to-do. So it will again be a mutation, delete to-do for user. For that we will be needing the user ID, which will be of type string, and the UID, which will be of type UUID. So mutation will be delete to-dos, where your user ID is equal to $user ID and the UID is equal to UID. We'll be just returning the affected rows out of it, and in our this section, let me go just give these two variables and let us see whether we get the affected rows as one. So the query works just fine. We'll just go and create the REST endpoint for it. So description user ID / UID, and we'll be giving this on a delete HTTP verb. So like that, we have all the REST points ready to be used in our application. And one more thing that we have to do for RBAC to work is, currently by default, since we have logged in as admin, all the permissions were of the admin, but we'll be creating a new role which will be the Hasura user, and that user will be having the insert for this to do table here, and it can select and update only the user ID where the Hasura user ID matches with those rows. Okay, so that kind of thing needs to be done, and also the delete will be active on that. So currently we are going to configure the RBAC for Hasura, and for that we will be inserting without any checks, no problem, toggle all. Okay, so with custom check, the user ID equals the X Hasura user ID. So in our JWT we are going to pass a claim, which the claim will be having the name as X Hasura user ID, and that X Hasura user ID will be what will be present in our table, the user ID table, not the to-dos table at the user ID field. So user can only select those rows where the user ID is equal to what is passed in the JWT token, and here's access to everything. So now we have defined this rule, we can just go select with custom select. GraphQL engine will automatically suggest us the same thing. Again, toggle all, save permission. Same goes for delete. So when we are configuring our Keycloak server, we need to be make it in such a way that your JWT contains this Hasura user role there. So let me go briefly on how this is going to work. So our auth server will be Keycloak here, and it will in the JWT it will be inserting some additional claims which Keycloak doesn't provide by default, and those claims will start from X. Hasura type of starting will be there in the claims, so those will be provided to our application. Our application will then go to your Graphql Engine endpoints, and it will provide in the authorization bearer tokens. So what we need to have for this to work is that in this claim namespace path is going to be this, and the X Hasura allowed roles should be there, default role should be there, and your X Hasura user ID should be there. So these three things should be there, and we will be configuring our Keycloak so that these three things are there. Again, one more important point is that the default role should be in the allowed roles list. So we'll go to Keycloak and just set it up. So Keycloak, as you can see, was running on this 2080 port. It was exposed outside the 2080 port. Inside the container it is running at 8080. So this is the admin console that we are going. The default password was username and password was admin. Okay, so first of all, when we are working with Keycloak, we have to add a realm. The master realm is just for management of all the other realms and everything, for the management of Keycloak itself. But for all intents and purposes of developing a application that uses an authorization server, you need to add your own realm. So we will be adding that. We'll be giving it a name of Hasura. Okay, just in your master realm, I'm switching it over again, going to the users. I'll be defining the admin email address. This is defined so that we are able to test all the emails, the SMTP server, the mailhog that we are running here. Currently, as you can see, it was running on 8025 port that we have defined here. So it doesn't have any emails. So switch back to our Hasura realm, and first of all, so we will be giving the host as mailhog. Since these both are on the same network, the demo network, we can directly access other containers by the name that we provide in the services. So we have given this particular mailhog container the name mailhog itself. If some other name was given, that can be put here in this field. 1025 is the default port where your SMTP connection works, and Hasura at localhost, this will be able to test this connection, and as you can see, the SMTP is working. Okay, we will just going to save this. Now for our application to actually generate tokens and everything, first of all we need to create a client in your Keycloak. So we are going to give it a name, Hasura app. First of all, that the first setting we are going to change is that access type. This is currently public. We are going to change it to confidential. So we are using OAuth plus OpenID protocol for authenticating and authorizing users to get the JWTs and everything. So it will be comprising of two requests. The first is the front channel request, from where we will redirect the user to this Keycloak login page. Their user will either they will register, or either they are already registered. If they are already registered, then they will enter their username and password, and once they have done that, it will redirect back to our site with the authorization code. Now this authorization code doesn't do anything by itself, but our back channel application, the server side part of our application, is going to use this authorization code, and it will provide contact with this Keycloak authorization server. It will say that I'm this client, my client name is Hasura app, this is my client secret, which nobody knows, and this is the authorization code that I got when a user was trying to log in. and can you please provide me TWT for this user so I can access the data that the user wants me to access. So it is much more secure than your any traditional type of access, because both the front channel and back channel communication make the entire flow very secure. So this is what everybody follows as of now. So we are going to provide the valid redirect URLs, which will be the localhost 3000 star, and we will be providing web origins. In web origins, don't add a star or anything, just so why we have to give this valid redirect URI. So when we are doing a OAuth 2.0 request, your authorization must need to know where to redirect, because in our front channel request we can give any redirect URI, but the problem with that is any person would be able to then redirect to his own domain. The URL can be malformed in your browser. So for that to work, for it to be secure, the Keycloak needs to know that it can only redirect to a certain domain. It cannot redirect to any domain. So for that to happen, for that thing to make secure, the redirection to make secure, we have to provide this redirect URI here. And again, for back channel request to work, because the RBAC channel will be directly communicating, it will be making a post request to your authorization server, and for that to happen, we need to provide the origins, so that we don't come across the problem of cross origin resource sharing, the CORS problem that we generally face when we are trying to gather resources from multiple sites. So these two things need to be provided here. We're going to just save this setting. Now once this is done, what we will do is we're going to, for rollback access control to work, we are going to define some groups here. So we are going to create a Hasura user group, and whenever a user is part of this group, we will be setting some attributes to it. So this is where this part comes in. All of these attributes we are going to set here. Okay, so hex Hasura default role Hasura user x Hasura allowed roles user. So whenever a user a part of this group, his we are setting two attributes to the user, and those attributes will be the default role and the allowed roles, and the value of them is going to be the Hasura user. We'll just save this. Now in our we go to our client, and now we need to pass this information inside our token. So for that we need to create a mapper. So first of all, we will be passing this user ID. So this is not the user attribute, this is the user property. So the mapper type will be the user property. The property name is going to be ID, and the token claim name, because this is the token claim namespace, we are going to be writing it like this. So here is a dot, and we want to separate it after the claims, so we are going to add a backslash x Hasura user ID, and this will be your Hasura user ID. It will be of type string. So just like that, we have created a mapper. Again, for next two attributes for this default role, so this will be in the user attribute. So the user attribute is going to be x Hasura default role, and the token claim name is going to be again backslash here x Hasura default role. Hasura default role. Attribute x Hasura allowed roles, token claim name Hasura allowed roles. So this is going to be multi-valued because the user can be part of different groups. So as you can see that this needs to be a list of roles that the user can take. So we'll be toggling on the multi-valued switch here. Allowed roles will be the name of this protocol mapper, and just like that we have all the things that we need for to be passed into our JWT token. So all that remains now is that we create a user, creating Tushar, Tushar at local host, demo, email verified. I'm going to select it as yes. Credentials, I'm going to set in the password. It's just going to be Tushar password, and I'm going to be joining a group called Hasura user. So this is the part which is very important, because if I don't join this group I won't have a JWT which is containing these two claims. So if I join this group, my user will be having these attributes set to me, and these attributes will be mapped by the protocol mapper into my JWT token. Just join this group. Going to client. The way to actually test whether I have a JWT, it is working or not. Just a second. Okay, no problem. We will directly test in our application. So now what we have to do is we will just first of all what we will do is go to this particular URL, the localhost 2020 where your Keycloak is running, then auth realms, the name of your realm, that is Hasura dot well known, and this OpenID configuration. When we click this, we will get this JWK URI. This is very important because we have to give Hasura this JWK URI, and using this JWK URI the Hasura will be able to validate whether our token is valid or it is just some fake thing that we have given it. So to verify the token validity, the Hasura will need this JWK URL. So for that to work, I will just give the JW. Now your this JWK URL will be passed in this format: JWK URL on.stringify x, just copying this from here, and I'm going to paste this here. Hasura Graphql Jwt secret. So just verify whether this is the actual key that we need to pass. Hasura Graphql Jwt. So that's the key that we need to pass. Okay, now I will just go and stop this Hasura Graphql Engine. Stop Graphql Engine. In your Docker Compose file, when you want to stop a service, you have to just give the name of the service that you have defined in your Docker Compose file. And that's going to stop it. I'm going to kill it, and then I'm going to start it again. Okay, so briefly going over our code, in your SvelteKit application, you will be, by default, what you will be getting is this, the hooks file, the index file, and the about file. The routes will be configured. In your route section, the first index.svelte file contains the default page that will be served when the slash path, the root path of your application is requested, and when the particular names, that like this about.svelte will refer to slash about, and if you make a folder and you make a file inside index.svelte, so this will be referred to as slash to-dos in your application. So this is the default structure of the Svelte to do demo app that we get. I have added certain things here, like this auth in your libraries. I have added this auth utils for just doing everything authentication related. Don't worry, everything, every code that I am showing here will be available on my GitHub, which will be linked in the video description. And one more thing that I have to do, I have to copy in the credentials section, I have to copy this client secret, and in my auth utils I will be pasting this client secret here. Okay, so this is needed, like you can see there are two functions here: initiate front channel OIDC auth and initiate back channel OIDC auth. I'll be needing this client secret for my back channel, and let's go and test whether our application is working or not. I'll just go to test. I'll just run npm run build and npm run preview. In my hooks file, what I'm going to do is I'm going to, once this is completed, I'm going to print the JWT token so that we can directly test request.locals.access token. That's going to restart my application. Okay, so this is the application. I'm running at localhost 3000 currently. Since I'm not logged in, my this request local access token is undefined, that is coming here. Okay, so if I go to to-dos part, I'll be redirected to the Keycloak. Here I'm going to enter the password, is showing me that object. No problem with that. Let me quickly grab the token that I have just printed. Okay, so this is the token. Let me go to the Hasura API and check the validity of this token. So to test with my token, I have to just make this authorization key here in the request header section, and I have to, in the value, I have to write bearer, then a space, and then I have to paste my token. I have to unselect this Hasura admin secret. Access key required. Actually, I have to reload it. Okay. Key required but not found. Authorization. Not showing. Problem with the header. As you can see, we have the user ID, allowed roles. Default role is not there. Did we do some mistake when we were defining our outputs? Access by default role. Okay, in our clients, did we find our mapper currently? Access default, just a spelling mistake, role. Okay, that is why I have to now regenerate the token. What I will do, I will go to the users section, just log out my session from here. Into my application. We're copying the JWT. Just paste from JWT. Let me test it again. So Hasura default role is now coming here, it's active. So user ID is also there, allowed roles is there. This key required. we do some mistake by defining the JWK URL. Okay, so do we need to provide this 8080 port to verify? Web origin. Spelling correct for authorization. Seems so that it is correct. Access required but not found. It is not letting me do this. No problem. What I will do is I will try to run my console on another part of my application. In our front-end application, it is showing the same error. It was not able to load. It was able to authenticate. So our authorization is working and we have all the claims that we need there. But this GraphQL engine is not working accordingly. No problem. We will make it work. So document. Need this GraphQL console part. Let me copy this compose documents docker compose hge.yaml. So here we have this SQL console part. I'm just going to copy and paste it here. So this is just the console application. The Hasura GraphQL Engine has a complete server, CLI and everything. So this was the image that was containing the GraphQL Engine part, the server part, and it is also having inbuilt a console. But there is a separate front-end application called GraphQL console, and I have custom built this image using the Circle CI Docker images given in the Hasura GraphQL GitHub repository. So don't worry, I'll be linking the description of how to build this image yourself in the video description box. So when this application runs, it will be running on this GraphQL console builder v1 part, and it will be having it will be exposed on 3000 and 3001. So let me go and okay, so what can I do? I can actually have a different Docker Compose file, because I wouldn't have to, no, I won't have to just start the service directly from here. Okay, Docker Compose start GraphQL. So no containers to start. The image is actually there. So why did it give an error? Starting the graph. Can I start a new Docker create? So now engine has also stopped. Okay. It is not able to fetch the GWK URLs. Okay, so the problem that it is getting is that we have defined the local host 2080 here, and it is not going to recognize this local host port. So what I'm going to do is I'm going to give it a network first, because for the local this container, the local host will be this container itself, but at the port 2080 nothing is running here actually. So I'm going to give it networks, the demo networks that I have created for it, and I won't be needing this GraphQL console after all. Okay, so this part needs to be go to this Keycloak, and Keycloak 8080 is going to be the port that is going to be the username with the IP address and port combination. Okay, so again I would have to give this Postgre also network demo network. Okay, I would have to stop Postgre and this stuff. I would have to Docker compose to stop GraphQL Engine first. then I have to stop Postgres. I would have to kill Postgres. I would have to kill the GraphQL engine. Then I will start Postgres. Start GraphQL engine. Hopefully in your logs, I think it is error fetching JWK. Still supported. So one way to get around this problem is that I can give the IP address of my system that we are currently running on. It is 192.168.1.4, and if I give that part 192.168.1.4 in T8080, it's actually running 8080, no problem. If I give that part, so it may work. Let me test. Compose, stop, GraphQL engine, kill GraphQL engine, and start GraphQL. Okay. Be giving the format as something let me try by removing the quotes from here. This is invalid. I have to provide the quotes. Not able to understand why it is having this socket problem. Cannot assign requested. Still accessing localhost. Why is that? Okay. Control space. To build the service again, maybe. Okay, if I do RM, it will remove it, then start. Okay, could not translate Postgres. Okay, no problem. So now we have got a solution, and how to do it. Let us keep it there. Now I think we don't need to give this. The Keycloak 8080 is definitely going to work. So what we have to do is we have to first rm the Graphql Engine. Yes, I'm sure. Then I have to rm the Postgres. Yes, I'm sure. Then I'm going to create Postgres. I'm going to start Postgres. Then I'm going to create the Graphql Engine. Then I'm going to start it. Let us see whether everything is good. So yes, we have finally succeeded in our quest, and let us go to our Keycloak. We have to first log out our user out of the session, then the application keys. First delete this cookie and go to those app. Good. Okay, so as you can see, now we have this to do part here, and I can just add to do smile. It is coming, and this means that our token is working. So let me just go and grab my token from here, and I will go to the console part. As you can see, it is giving the message JWT expired, so it is able to verify now. And as soon as I type this, all the mutations and queries are coming, and there is a button here, Decode Jwt. It has this verified the token validity here, and all of the claims that it needed are there. So whatever the token that your Keycloak was generating, it is being accepted for the role-based access control of Hasura, and now we don't need our users to actually have admin permissions to work on a database and everything. So we have achieved a major part. We have actually learned how to configure your Hasura, how to define the REST endpoints on Hasura, how to create a tables, define your fields on that, and how to configure Keycloak, how to configure your Hasura claims into your JWTs. So we have learned all that, and in the next part of this video we are going to focus upon how we have modified the default SvelteKit to-do application to actually work with this Hasura and Keycloak together and get all the to-dos and everything. And as you can see that we can create more to-dos, eat, code, we can just change the to-dos, and we can see that whatever the changes we are doing, they are getting affected in the table. So if I just go and just mark this Eden code as completed, currently this Eden code completed is done as false. If I mark it as completed here and run my query again, so it is true now. So we now know that just save it and just query it. So the patch part is also updating. If you want to delete it, so now the delete part is also updating. So the creation of to-dos, the updation of to-dos, the listing of to-dos, and the deletion of to-dos all is working with the JWT token that was provided by the Keycloak, and it is accepted by Hasura, and Hasura has accepted it, and accordingly our REST endpoints are also working. All of the REST endpoints, these 4 REST endpoints that we defined based on the queries, these are also working. So the important part here is that we now have some ways to work upon, and now we can go in depth in when we are modifying this to-do application to actually know that how we did what we did. So thank you all for watching this video. Please like, share and subscribe. So I know that this is a bit of a long video, but I hope you guys have enjoyed it, and we were able to finally do some debugging on the fly as well. So sorry for taking everybody's time, and see you soon. Bye bye, take care.